So the exit ticket for lesson 13 says a popcorn box is in the shape of a right rectangular prism as shown. The popcorn box does not have a lid. How much cardboard is needed to make one popcorn box? So what we want to find is the surface area of everything minus that top part. So we know that we need to identify our height, our length, our width. So in this problem, I'm going to use 3.5 as my height. I'll use 6 inches as the length, and I'll use this 3.5 inches as the width. To find surface area, our formula is surface area equals 2 times height times length plus length times width plus width times height. And remember, those letters can be switched around. So let's look at our first one that we have. So we want to go ahead and plug in the height times the length. So I'm going to rewrite this, and I'm going to actually put the product of those two variables. I'm going to put their products. So for the first one, we have 6 times 3.5. That's going to give us 21 for the height times the length. Actually, I just remembered for this one, because there's no lid, the height times the length, that's going to be okay for this one. But our bottom, the length times the width, will not have a second one. So I'm going to separate this. I'm going to do height times length, which is that one. So we're going to put that one in there, 21 plus. Now, the length times the width is the base right now. So we want to make sure that's going to be outside of our parentheses. And we'll be able to add that to it. So the length times the width, we have 6 times 3.5 again. So that's going to give us 21 that I'm putting out here. The only reason it's not going inside is because these are going to be multiplied by 2, because all of the other pairs of rectangles have their paired side except for the base. So then the only one that I'm missing now is going to be width times height. So when we do W times height, you get 12.25. So from here, you're going to multiply, well, you're going to add 21 and 12.25. Get that total, multiply it by 2, then add 21. So let's see what that looks like. Rewrite this. Surface area equals, so inside I'm going to have 2 times. So we have 21 plus 12.25 gives us 33.25. And then it's plus 21. So then when you multiply those two particular numbers together, 2 times 33.25, you're going to get 66.5, and you want to add 21. And so we get a grand total for our surface area equals 87.5, and that's inches squared. And that completes the exit ticket for lesson 13. Alright, so the practice problem, well, the first practice problem for lesson 13 says, at a store, shipping boxes are shaped like rectangular prisms. The shipping boxes come in 3 sizes: small, medium, and large. So part A wants us to determine the surface area of the small shipping box. So the first thing we'll do is determine the surface area of the small one. So we know that our 3, we're going to have 3 1/2. This will be our height. I'll do 10 inches as our width, and I'll do 7 inches as our length. We know surface area 2 times that length times width plus width times height plus height times length. Okay, so there's our surface area formula. So we want to do the first one, and I'm going to write these over here just because we don't really have room. So this is for the small. So the first one I have 7 times 10, which is 70. Next we have width times height. So that means we're going to have 10 times, and then 3 1/2 is like saying 3.5. So 10 times 3.5, that's going to give us 35. And then the last one we have is height times length. So for that one, we're going to have 7 times 3.5. Remember I said that 3 1/2 is the same as saying 3.5. So you get 24.5. And then to find the surface area, you just want to add all of those up and multiply by 2. You're going to get 259 inches squared. Next, we have the medium box. So for our medium box, we're going to do this as the width, height, and length. So keeping with the same formula that I wrote up there, we have length times width. So in this case, that's going to be 14 times 20, which is going to give us 280. Plus, the next one we have is width times height. So 20 times 7 is going to be 140. And then the last one we have is going to be height, which is 7 times the length, which is 14, and you get 98. So we want to add those up, multiply by 2, you get a grand total of 1,036, and that's inches squared. Alright, and then the last one is the large shipping box. So we want to identify this is the width, this is the height, and this is the length. So the first one that we want to do is going to be length times width. In this case, that's 28 times 30, which is going to give us 840. Alright, our next one we have is width times height. So we have 30 times 14, which gives us 420. And then we have last height, which is 14 times length, which is 28, and that gives us 392. We add all of this in the parentheses up, and we want to multiply by 2, and when we do, we get 3,304, and that's inches squared. So part D says the company makes the shipping box use 103,600 square inches of cardboard to make 100 same size shipping box. Which shipping box does the company make? And justify your answer. So If it's 103,600 and it's 100 same size, that's definitely going to be the medium size, because 103,600 divided by 100 is going to equal 1,036. So if they're using 100, it makes 100 boxes using this amount. You just divide by that amount and you find that it would be the medium sized boxes that shipping company is making. All right, so that completes that particular part. Let's look at the next part of our practice problem. All right, so there was another part to this particular problem, and it involves the small shipping box. So I had already cleared the screen, but remember that this was 259 square inches for the small shipping box. We'll need that information for the next part. So part E says the cost of the cardboard the company uses to make these shipping box is 72 cents per square foot. And we want to know what is the total cost of cardboard to make 1,000 small shipping boxes. So we know that this is actually in inches, but we know that 1 square foot is equal to 144 square inches, because we know there's 12 inches in 1 foot. Square inches, okay. So we know that there is 144 square inches in 1 square foot. And if there are 72 cents for 1 square foot, we want to do 72 divided by 144 so we can find out the cost per square inch. And so when we do 72 divided by 144, we find out that the cost is 50 cents each. Okay, so now that we know that per square inch is 50 cents, we can identify now how much it would cost for 1 box. So we would take 50 cents and we're going to multiply that by the amount that we found for the surface area of the small shipping box, which was 259. So we have 50 cents times 259 gives us a cost of $129.50. So if we want to find the cost it takes to make 1 shipping box, we want to do $129.50, and we want to multiply that by 1,000 because we know that there are 1,000 small shipping boxes. So when we multiply, we found that total to be 129,500. And actually, I was thinking this is actually representing cents, not dollars. So I need to adjust that. This particular price right here, this is representing cents. So it's 129.5 cents. Okay. And so then here we have 129.5 cents times 1,000 gives us 129,500. But when you're talking about cents, you know that you divide that by 100 to find the dollar amount. So the total cost would be $1,295. All right. I know that was a lot. Again, we know that 1 square foot is equal to 144 square inches. We know that the cost per square foot was 72 cents. We did 72 divided by 144, and we got that each of those was 0.5. And so then we multiplied that 0.5 times 259, and we got 129.50. And then we multiplied that by 1,000, which is the number of boxes there were, because this represented the amount of cents per box. So then we multiplied, and then we found out that for 1,000 boxes, it would cost $1,295 to make those boxes. So let's look at number 2. Let's look at number 2. A gift wrapping company designs a gift bag. Paper is used for all sides except for the top of the gift bag, which is open. Consider the company's 2 designs. Which design makes a gift bag with less surface area than the other? So for this one, for surface area, we want to represent 10 times 12. So we're going to have 2 times 10 times 12 because there are 2 of these spaces. The only thing that they said is open is the top. So that means our base, when we do 10 times 4, will only be represented once. Next, we also have 4 times 12. So that's that side, these sides over here. So I'm going to add to that, and we'll have 2 times, and we have 4 times 12. And then the last one I have is the base, which is going to be 10 by 4. And we're only going to have one of those. So we have 10 times 4. So next, I want to do SA, that's surface area. It's 2 times 10 times 12 is 120. Plus 2 times 4 times 12 is 48. Plus 10 times 4 is 40. So next we want to combine. So 2 times 120 is going to be 240. Plus 2 times 48 is 96. Plus 40. And we get a grand total of 376. So I'm going to put that in here. 376 inches squared. So I got to go and erase down here because I need to, well, I can write on the side. It's fine. Okay, so we're going to do the same thing over here for the surface area. I'll do this one in pink so that you know the difference. So we have the surface area. So the first one, we're going to have 10 times 11. So I'm going to have 2 and then 10 times 11. I know that 10 times 11 is 110. So we'll go ahead and write that down there. Plus, the next one will be 10 times 3.5. So we're going to multiply it by 2 because we have 2 sides. And that's 3.5. Okay, and so 10 times 3.5 is 35. So we have 2 times 35 plus, and then the last part that we need to add to this, I'm running out of space, that is where we're going to have the 11 times 3.5. So I'm out of space right here, but we have 11 times 3.5. All right. So when we do 11 times 3.5, well, let's come down here. So we have SA equals 2 times 110 gives me 220. Plus 2 times 35 gives me 70. And remember, the 11 and 3.5, we don't have a top, so it's only the base. So when I did 11 times 3.5, I got 38.5. So we want to add up all of those sides, and when we add them up, we get a surface area of 328 and 5/10. And so in the problem, they said which design makes a gift bag with less surface area than the other. So it's going to be design 2 has less surface area than the gift bag made with design 1 because 328 and 5/10 square inches is less than 376 square inches. Part B of this problem says the cost of the paper. So we're going to clear this off and go to that next page. But just remember your answers. So the cost of the paper to make the gift bags is 1 cent per square inch. So what is the cost of the paper to make one gift bag by using design 1? So luckily for us, this time they actually had it in inches already. So we know that the area for design 1, the surface area was 376. So we want to multiply 376 by 1 cent. and we get $3.76. Okay, and it said, what is the cost of the paper to make one gift bag by using design 2? So for this one, we had the total square footage was 328.5. So we would want to do 328. Let me see here. Yes, 328.5. Sorry, I had to go back to my answer. And we want to multiply that by 1 cent. And we will get, whoops. We get $3 and, well, we get 3.285, but we're talking about money, so we want to round that up to $3.29. Number 3 says, a shoebox company creates a shoebox with a lid as shown. Cardboard is used for all sides of the shoebox except for the top, which is open. Cardboard is used on all sides of the lid except for the bottom, which is open. Consider the diagrams of the shoebox and the lid. How much cardboard is needed to make one shoebox? So in this particular case, for these, I'm actually going to turn this to 9.5 as a decimal, 18.25 as a decimal, and 24.5. So to find how much you need, we have to multiply everything. So we have a lot of math to do. So we're going to multiply this times this times this, and also this times this. So give me a second. I will come back with those totals. Alright, so the first thing we have is we'll do 9.5 times 24.5. So we have 9.5 times 24.5. That gives us 232, and that's 0.75 or 75 hundredths. The next one we have is 9.5 times 18.25, and we get 173, and that's 375, which is also equal to 3/8. Okay, so just in case you were wondering, when we multiply that, that's equal to 3/8. This is 3/4. All right, moving on. Let's see. The next numbers that we need to multiply will be 18.25 and 24.5. Those are going to give us 447 and 125 thousandths. All right, so from here, we know that this shoebox does not have a lid. It doesn't have a top. So that means that this bottom portion, which represents this side by that long side, our base, that will not be multiplied twice. However, the pink and the blue, which represent the sides of the shoebox, those will be multiplied twice. So when we multiply them twice, for the first one, let's get the pink. So we have, see, 232.75. So we have 465.50. Then we want to add, we're going to go to the blue, which is 173 and 375 thousandths. When we multiply that by 2, we get 346 and 75 hundredths. And then we want to just add the green to that amount, which gives us 447 and 125 thousandths. And we have a grand total of 1,259, and that's in 375 thousandths or 3/8. And then next it said how much cardboard is needed to make one shoebox lid. So we had to do the same thing for the shoebox lid. So the first one that I did was 25 times, where am I at? 25 times 3.5, sorry. My handwriting is really small. 25 times 3.5, we get 87.5. And so this represents this little portion right here. And there are 2 of those, so we want to multiply that by 2. And we are going to get 175. Then our next one, we have 19 times 3.5. So that represents our side right here. We have 19 times 3.5, so that will be represented twice. So we get 66.5. We want to multiply that by 2. So we get 133. So the only thing that's not represented twice is our 19 by 25, which is our top. So we want to represent that just once. So we have 25 times 19, which is going to give us 475. And then what we do with this is we want to add 175 plus 133 plus 475, and we get a grand total of 783 is the amount of cardboard that's needed to make one shoebox lid. So this is the port that goes right here. We have 783. And then for the last one, it wants to know the total amount. So total amount is 2,042 and 375 thousandths, or if you kept it as fractions, 2,042 and 3/8. All right, and that completes that problem. So let's go ahead and look at our next problem, number 4. Number 4 says a company makes play tents for children. The tent is shaped like a square pyramid with the measurements shown. Fabric is used to enclose the entire tent, including the bottom. How many square feet of fabric are needed? So we know with a square pyramid, the bottom is a square. So we know that this is 3.5 by 3.5. So to find the area of a square, you want to do S squared. So what that means is we're doing 3.5 times 3.5. And when you do that, you get 12.25. So that's the area for our square. Now we have 4 identical triangles surrounding it. And the area for triangle is found by base times height divided by 2. So in this case, we have 3.5 times 5, because that's our height. And then we want to divide that by 2. And we get a grand total of 8.75. So that is the area for one of those identical triangles. However, we have 4 of them. So we need to do 8.75 times 4 to find out the total area for all of the triangles. And we get that that area is 35. And that's feet squared. Sorry, I don't think I have been labeling today. I apologize. And so then to get our total, you simply add those 2 together. And so we know it's 47 and 25 feet squared. Says the cost of the fabric is 40 cents per square foot to make the tent. What is the total cost to make the tent? So we take 47 and 25 and we multiply that by 40 cents. And the cost is going to be $18.90. Number 5 says a cube-shaped storage bin with an open top has a surface area of 80 square feet. Find the area of one face of the storage bin. Well, we know a cube has 6 sides, but one of those sides is missing because it has an open top. So we would simply do 80 divided by those 5 sides, which would tell us that the area of one of the faces of the storage bin is 16. So it says find the edge of the storage bin. Or again, surface area for a cube is S squared. Okay, that's how we find our surface area. And then normally you have 6 of them, so it's 6S squared. But if S squared is equal to 16, then you want to find the square root of 16, which is going to be 4. 4 times 4 is what will give you 16. So that completes number 5, and we know it has a side length of 4. Let's go ahead and look at number 6. The area of each face of a right rectangular prism is shown on the net. Which of the following are the dimensions of the prism? So that's us determining what they're being multiplied by. So we have 10 and 45 here. So that tells me, I know that this side right here going up and down vertically is going to be 5. These are going to be 2 because 5 times 2 would give us 10. So then 5 times what gives us 45? So we know that's 9. 9. This would be times 2 would give us 18. Again, we have another 9 and 5 and 5. And here another 9 and 2 and 2. And we know this is 9. So our side lengths are 2, 5, and 9. So you want to find the one that matches that, and that is D. So that completes that page for our practice problems. Let's look at the next page. Okay, for problems 7 through 10, they want us to just use keep, change, flip when dividing fractions. We've had a lot of practice with this lately. So again, when I rewrite it, I'm going to write it in its new form using keep, change, flip. Just as a reminder, we keep the first fraction, change division to multiplication, and flip our second fraction and find its inverse. So here we have 7/10 times 3 over 2, and so we get 21 over 20. Our next one, we have 9/5 times 4 over 3, and then we get 36 over 15. Our next one, 8 over 2 times 6 over 5, we get 48 over 10. And then our last one, 6 over 13 times 5 over 2, we get 30 over 26. Okay, number 11. I'm going to clear this and scroll up, or scroll down actually, so I can see the rest of it. Use the square pyramid to answer parts A and B. On the grid, draw a net of the square pyramid. Label all measurements in the net. So we see the square pyramid, it has a side of 4. We know that all squares have the exact same size, so I'm going to come right here and draw a 4 by 4 square. Okay, so I have my 4 by 4 square. I'm going to label 4 and 4 centimeters. So next, we need to draw the 4 identical triangles that surround it. They have a height of 6. So that means when I draw out, I want to make sure 2, 3, 4, 5, 6, that I'm going up 6. 1, 2, 3, 4, 5, 6, See, I'm placing my dot right there in the middle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so from here, I'm just going to connect. I know it's not perfection, y'all. And then next thing we want to label. I'm going to label on this side away from the 4. We want to label that is 6 centimeters. And so now we have everything labeled. It wants us to calculate the surface area of the pyramid by using its net. So first thing, we calculate the surface area of the square. We know 4 times 4 gives us 16 centimeters squared. And that is for the area of a square, which is S squared. The area of a triangle equals base times height divided by 2. So in this case, we have 4 times 6 divided by 2. That gives us an area of 12 centimeters squared. However, there are 1, 2, 3, 4 of those. So we need to do 12 times 4, which gives us 48 centimeters squared. You add those two together, 48 plus 16, and we get 64 centimeters squared. Let's look at our next page. Lacey runs for 30 minutes each day that she runs. Let D represent the number of days that Lacey runs. Let M represent the total number of minutes that she runs. Determine the independent and the dependent variable and explain your reasoning. So our independent variable, and you know I always abbreviate that with IV, is going to be D, the number of days that Lacey runs, and our dependent variable is going to be M, which represents the total number of minutes that she runs. And the reason being is because the number of minutes that she runs depends on how many days that she runs. And then it wants us to write an equation that represents the relationship between the total number of minutes that Lacey runs and the number of days that she runs. So she runs 30 minutes per day. So we want to let M equal 30D, because the number of minutes depend on the number of days. And then complete the table. So in one day she runs 30 minutes, 2 it'll be 60, 3 it'll be 90, 4 it will be 120, and 5 it will be 150. And that completes the practice problems for this lesson.